We'll start things off with NASA capturing images of what appears to be the strongest solar flare of the year so far. The agency's Solar Dynamics Observatory capturing images of multiple events on the sun's surface, including one solar flare that clocked in at a class X, NOAA's most powerful classification, by the way. Energy from strong flares are known to disrupt communications right back here on Earth. And sure enough, as space.com reports, following that event right there were radio blackouts reported in Europe, Asia, and the Middle East.
At 8:25, radios across Europe, Asia, and the Middle East fell silent. An X 2.7 class solar flare, the strongest of 2025, exploding from sunspot AR 4087. It hit Earth at light speed, supercharging the upper atmosphere and frying communication systems in seconds. In today's video, we'll unpack what happened, why it matters, and whether the next one could knock out satellites, power grids, or worse. On May 14, 2025, at exactly 8:25 UTC, the sun erupted. From a dangerously unstable sunspot named AR 4087, a massive solar flare exploded into space, classified as X 2.7, the most powerful of the year. Within a second, a surge of radiation slammed into Earth's upper atmosphere, triggering blackouts and scrambling communications across 3 continents. Solar flares are ranked by intensity from A to X. This one, nearly 3 times stronger than a standard X-class flare, and it didn't come out of nowhere. Just a day earlier, that same sunspot had fired off an X 1.2 and an M 5.3. Scientists were already watching it, but they weren't expecting this. Was this the peak or just the beginning? When the X 2.7 flare erupted, it blasted the Earth's upper atmosphere with intense X-rays and ultraviolet light. This energy quickly ionized a layer of the atmosphere called the D layer of the ionosphere, which is important for radio communication. The sudden increase in charged particles caused major problems with high-frequency radio signals on the side of the Earth that was facing the sun. As a result, radio blackouts were reported in many parts of the world. Although this flare didn't send a coronal mass ejection, a huge cloud of solar particles toward Earth, scientists are still keeping a close eye on AR 4087. As this sunspot region slowly turns to face Earth more directly in the coming days, the chances of Earth being hit by a coronal mass ejection grow. If that happens, we could face strong geomagnetic storms, which might disrupt satellites, power grids, and even cause stunning auroras near the poles. The sun once again showed how powerful and unpredictable it can be, and how its activity, even 93 million miles away, can affect life on Earth in just seconds. Right after the X 2.7 class solar flare erupted on May 14, 2025, its effects were felt around the world. In many parts of Europe, Asia, and the Middle East, high-frequency radio signals suddenly stopped working. This caused serious trouble for airplanes, ships, and even emergency services, which depend on these radio waves to send and receive messages over long distances. The event showed just how fragile our modern communication systems can be when hit by space weather. The flare caused a disturbance in Earth's upper atmosphere, specifically in a region called the ionosphere. This area is important for bouncing radio signals across the globe. But when the solar flare hit, it added extra energy to the ionosphere, causing it to absorb the high-frequency radio waves, those in the 3 to 30 megahertz range, instead of reflecting them. As a result, high-frequency radio communication either became very weak or stopped working entirely in the affected areas. This was a big problem for industries that rely on this type of communication, especially for flights over oceans and remote areas, where ground-based communication isn't available. But the problems didn't stop there. Solar flares like this can also mess with satellites and navigation systems. The extra ionization in the atmosphere can slow down or block signals from global navigation satellite systems, including the widely used GPS. That means GPS devices might give incorrect positions, which can be dangerous for planes, ships, and even people using navigation on the ground. Satellites orbiting close to Earth can also be affected. The solar energy heats up Earth's outer atmosphere, causing it to expand. This increases the air resistance, or drag, on satellites. which can change their orbits and make them drift off course. Although this particular flare didn't launch a large burst of solar material known as a coronal mass ejection, the active sunspot region that caused it is still active and might release a coronal mass ejection in the future. Coronal mass ejections are powerful solar explosions that can create geomagnetic storms when they reach Earth. These storms can knock out power grids, speed up the rusting of pipelines, and increase the amount of radiation that airplane passengers and astronauts are exposed to, especially at high altitudes. Recently, the sun has been showing us just how powerful and unpredictable it can be. Recent solar flares, those massive bursts of energy from the sun's surface, have served as a fiery reminder that we live in the shadow of a star that doesn't always play nice, especially in our modern world that depends so heavily on technology. Scientists say we are getting closer to the peak of solar cycle 25, a period of increased solar activity that is expected to hit its high point sometime in late 2025. As we get nearer to this solar maximum, experts are seeing a clear and dramatic rise in the number and strength of solar flares. The most dangerous kind, X-class flares, are becoming more frequent. These are the strongest types of solar flares, and they can have serious effects on Earth. Over the past couple of years, the sun has been especially active. It's been behaving like a restless giant, constantly bubbling with energy. In May 2024, one particular region of the sun, called AR 3664, exploded with an X8.7 class flare, the biggest of that year, and one of the most powerful we've seen in decades. That eruption sparked a G5 geomagnetic storm, the strongest level possible, and caused spectacular auroras, or northern lights, to appear in places as far south as Texas and Spain. But it wasn't just pretty lights in the sky. GPS signals went haywire, radio communications were scrambled, and airplane flight paths had to be changed for safety. And that was just the beginning. A few months later, in February 2024, the sun blasted out another powerful X6.3 flare, and then, on October 3, 2024, it unleashed a giant X9.0 flare, a true solar monster. Not all of the energy from these flares hit Earth directly, but they made one thing very clear. The sun is entering a particularly wild and unpredictable phase. Because of this, scientists and space agencies have been sounding the alarm. They're warning that more big flares are likely on the way and that we need to be ready. So far in 2025, the sun hasn't calmed down. On May 13th, a sunspot called AR 4087 released an X1.2 flare, followed just hours later by an M5.3 flare, and then, on May 14th, a stronger X2.7 flare came from the same region. This cluster of eruptions in such a short time wasn't just a coincidence, it was a sign of something bigger brewing. Sunspot AR 4087 is still rotating toward Earth, and experts are keeping a close eye on it. It could still launch powerful solar storms in our direction. To better understand and prepare for these kinds of space weather events, organizations like NASA, the European Space Agency, and NOAA's Space Weather Prediction Center are watching the sun closely. They're using advanced tools like the Solar Dynamics Observatory and the Parker Solar Probe, which fly close to the sun and collect data about its activity. These missions help scientists spot patterns in solar flares, and more importantly, give Earth an early warning when a dangerous flare or coronal mass ejection is on the way. A solar flare travels to Earth at the speed of light, so we feel the effects almost instantly. But coronal mass ejections, which are huge clouds of charged particles that the sun throws out, move slower, often taking several hours or even days to reach us. That delay gives us a precious window of time to send out alerts, prepare satellites, protect power grids, and reroute airplane flights if necessary. Still, predicting exactly when and where a flare or coronal mass ejection will hit is incredibly difficult. Some flares don't send out coronal mass ejections at all, and some coronal mass ejections go in other directions entirely. Scientists are still working hard to make space weather forecasting as reliable as Earth weather forecasting. Because of these growing solar risks, many governments and companies are investing in ways to protect our infrastructure. They're looking for better ways to shield satellites, make electric grids stronger, and build backup systems for GPS, military communications, and air travel. But technology isn't the only answer. Education and public awareness are just as important. Just like we learn how to prepare for hurricanes or earthquakes, people need to understand what solar storms are and how they can affect our daily lives. For example, during times of high solar activity, pilots are given special briefings, and airlines may avoid routes over the poles, where solar radiation is strongest. So when the X 2.7 flare hit on May 14, 2025, it wasn't just another bit of space news, it was a warning shot from our sun. One more puzzle piece in a growing pattern of extreme solar behavior. This solar cycle is far from over. As we move deeper into 2025, the sun's activity may keep increasing. That means we need a coordinated global effort to monitor the sun, to model and predict its behavior, and to prepare our technology and our people for what's coming. Why scientists are worried? Lately, the sun has been acting strangely. It's been sending out huge solar flares and massive explosions of hot gas called coronal mass ejections. These blasts are stronger than anything we've seen in recent years. When this happens, tons of charged particles shoot out from the sun and can slam into Earth. This can mess up our satellites, damage power lines, and even interrupt the internet. Scientists are worried because the sun is entering a very active phase called the solar maximum. This happens every 11 years when the sun's magnetic field flips, causing a lot more solar storms. The stronger the activity, the more damage these storms can do to Earth. One of the biggest fears is another storm like the Carrington Event from 1859. That was the most powerful solar storm ever recorded. It knocked out telegraph systems all over the world. Some even caught fire. If something like that hit today, it could cause enormous damage to our technology-based world. In 1859, a British astronomer named Richard Carrington was watching the sun through his telescope when he saw a sudden, bright flash. It lasted about 5 minutes. What he saw turned out to be the biggest solar storm in history. The sun had fired a huge burst of hot plasma straight at Earth, and it caused chaos. Gold miners in the Rocky Mountains thought it was morning at 1 a.m. because the sky was glowing so brightly from the northern lights, also called the aurora. Telegraph systems around the world started working without any power, just from the energy of the storm itself. Messages were being sent with no electricity at all. In Australia, people saw bright red auroras lighting up the sky. A local newspaper at the time described the sky as glowing with a gorgeous hue of red. That storm was massive, and yet it missed most of the modern technology we rely on today. But in 2012, another storm nearly as strong just missed Earth by 12 days. If it had hit, it could have caused a major global blackout. Solar storms keep happening because the sun works in cycles. Every 11 years, its magnetic field flips, which leads to lots of solar activity like flares and coronal mass ejections. The current cycle started in 2019 and will reach its peak, the solar maximum, in 2025. During this time, the sun becomes very active and the risk of a powerful solar storm is higher. What's even scarier is that scientists found signs of even bigger solar storms in the past by studying tree rings. In the years 774 and 994, trees captured traces of massive radiation spikes, likely from solar superstorms much stronger than the Carrington Event. Some might have been 10 or even 100 times more powerful. Today, we rely on electricity for everything: our lights, phones, internet, cars, and even hospitals. If a storm like the Carrington Event hit us now, it could shut down the world's power grids for years. Some scientists estimate the damage in North America alone could cost $2.6 trillion. There would be worldwide blackouts, no internet, no GPS, and no lights, just the stars in the night sky for the first time in centuries. The biggest danger is high-voltage transformers in power stations. They're extremely hard to replace, and without them, we can't get the power back on quickly. Satellites in high orbits would also be in big trouble. They'd get bombarded with high-energy particles, and many would be damaged or destroyed. These satellites control our communication systems and GPS. In fact, Starlink already lost $50 million worth of satellites to a solar storm. Even astronauts working on future moon bases would be at risk, as this kind of radiation is harmful to human health. We can't stop the sun, but we can prepare. Spacecraft like the Solar and Heliospheric Observatory, SOHO, keep an eye on the sun. If they detect a coronal mass ejection coming our way, we usually get 12 to 48 hours warning. That short window is vital. Governments can shut down power grids, people can unplug electronics, and satellites can go into safe mode. To protect small devices like phones or laptops, people could wrap them in foil to shield them from the radiation. Hospitals and emergency services will need special backup systems to keep running. Some cars would be okay, but many of their electronic systems like touchscreens or backup cameras could be destroyed. What do you think of this incredible solar flare? Could the sun destroy the Earth in 2025? Let us know your thoughts in the comments. Subscribe to Space Aquarius for more astonishing space discoveries.